Kiran ma'am, should we start?
Yes, ma'am. Am I audible, ma'am?
Yes.
Okay. So, should we start?
Yes, ma'am, let's start.
Good afternoon, everyone. I, Professor Kiran Ghate, welcome you all to the day 4 of FDP on cybersecurity and ethical hacking, concept tools and investigate techniques, organized by Department of Electronics and Telecommunication of Shalaka Foundation, Keystone School of Engineering. Today, session will be conducted by Mr. Krishna Kulkarni, Technical Manager, Numo Data. It is my great pleasure to introduce our distinguished resource person for today's session on ethical wireless hacking. We are honored to have with us Mr. Krishna Kulkarni, a highly accomplished technology leader and expert in the field of networking, telecom, and wireless technologies. Mr. Kulkarni brings over 20 years of rich industry experience in driving large-scale technology initiatives, engineering excellence, and innovation across the telecom networking and wireless domain. Throughout his professional journey, he has successfully led complex projects and mentored teams in advanced networking and wireless technologies, making him an expert to guide us through today's topic. His extensive experience includes managing large-scale monitoring portfolios involving TCP/IP, ping, TWAMP, and SIP technologies, along with deep involvement in network performance, security, and protocol analysis. His expertise in vulnerability scanning and analysis provides valuable insights into identifying security weakness and strengthening wireless network defenses. Mr. Kulkarni has also played a key role in implementing modern engineering practices, including CI/CD, automation first approaches, and cloud native architectures using Docker. His strong understanding of networking protocols, observability, and system security enables him to bridge the gap between theoretical concepts and real world cybersecurity challenges. He graduated in electronics and electronics engineering from Pune University. Mr. Kulkarni possesses deep expertise in networking, telecom, vulnerability assessment, and protocol development. His commitment to equality, quality security and continuous learning has earned him recognized as a respected leader and mentor in the technology industry. In today's session on ethical wireless hacking, he will share valuable insights into wireless security concepts, ethical hacking methodology, and best practices for securing wireless communication systems. On behalf of our organizing team or organizing committee and all the participants, I extend a warm welcome to Mr. Krishna Kulkarni sir. Welcome, sir. Now I would like to invite Mr. Kulkarni sir to take over the session and share his valuable thoughts. Hand over to you, sir.
Thank you, Kiran ma'am. I hope I'm audible.
Yes, sir.
Great. Thank you. Okay. Good afternoon, all to all the faculty members. Good and big introduction. Thank you, Kiran ma'am. So today I'm here to explain or talk about ethical wireless hacking. It's an interesting topic, and let me share my screen so that we can take this forward. Let me know if my screen is visible. Okay. So let's start. To start with, we are going to cover these contents that we have on the slide today. We will discuss about the basics of wireless networks, what all wireless standards we have or the Wi-Fi standards we have, uh, what is the architecture of Wi-Fi, which is 802.11, what are different threat metrics, what security we have to safeguard those threat metrics, what are different modes of the NIC connectivity. We will do some practicals with Kali Linux, and we'll have some practical sessions using Kali. So to start with, basics of wireless networks. Now, I know to start with a question is not very acceptable to all, but I would like to ask a question here. Like, when you hear about wireless networks, what comes in your mind? Can someone tell me? It's day to day we use. What are few things that we use daily and that are wireless? Can someone talk about it? Faculty members, we are not students here, so we are all faculty. Anyone?
Mobile.
Very good. That's one. What else? Okay. Dr. Saurabh, Dr. Sanjeev, Alok. Yeah, I see internet, mobile phones, Wi-Fi, Bluetooth device. Excellent. Those are the answers I was looking for. Great. Thanks a lot. Yeah, these are few things that we use on daily basis. There's one more thing that we use on daily basis, which is IR, infrared, which we use on daily basis. Then we have Zigbee, which also I would introduce today. Okay.
Security and ethical hacking. Cyber security and ethical hacking.
Someone's not on mute.
Oh, sorry.
Yeah, no problem. Okay. So we will start with Wi-Fi, and that would be our main topic for today, overall discussion. Wi-Fi is wireless fidelity. It's a technology that allows devices to connect to internet or local networks wirelessly using radio waves. It primarily works in 2.4 gigahertz and 5 gigahertz bands, frequency bands. However, the new standards, which is Wi-Fi 6 and Wi-Fi 7, works on 6 gigahertz bands as well. Now, till in recent days, like in Jan to 2026, The 6 gigahertz bands, the lower part of the 6 gigahertz band is approved in India. So we will now have Wi-Fi 6 and Wi-Fi 7 as well in India. It was not there till now. So it's a simple concept. We all have routers, wireless routers or access points at home. We connect our devices to those wireless access points and routers, and we get wireless internet. The speed ranges from it goes up to a good speed, and the overall range is up to 100 to 300 feet. So that's the range we have, and it's very much used in homes, businesses, and public spaces. About Bluetooth, it again operates in 2.4 gigahertz. Its range is less, typically 100 meters, and we all know we use Bluetooth at many places. Like we use it in our smartphones, headphones, keyboards, speakers, multiple places we use Bluetooth. It's very much used by everybody in day-to-day life. The newer versions, Bluetooth 6.0, offers faster speed, longer range, up to 240 to 300 meters range. It has better efficiency, and in 6.0 even we have a centimeter level accuracy. Till Bluetooth 5.0 we only had the other three, but in 6.0 centimeter level accuracy is also a part of Bluetooth 6.0. Okay, the next one is cellular. Everybody talked about it. We have 2G, 3G, 4G. Not to speak much. We have towers with which we connect to our mobile phones. We connect to the towers, and that's how we get the connectivity. We have a specific SIM with which we connect to the towers. It belongs to a particular provider, so it's all well known to everybody. IR is also well known. This is basically we use it in remote controls. It needs a line of sight, so it differs from Bluetooth uh, a bit, because here the important is we need a line of sight. So it's the distance is short as compared to other wireless devices, but it needs a line of sight to get connected. And we have Zigbee. It also operates in 2.4 gigahertz frequency band. Uh, it is majorly used in IoT applications such as smart home. So, and Zigbee is very well known for its mesh networking capability. So devices can relay data from one entity to the other entity, creating a mesh and extending the network's range. It also uses a low power, so it's ideal for the battery powered devices. So that's about the different wireless uh, mechanisms or wireless standards we have. Now we'll talk about Wi-Fi standards specifically, because now we are going to deep dive into wireless, which is Wi-Fi, which is one part of the wireless. Wi-Fi is one part of wireless, I would say. So Wi-Fi standards, it is IEEE 802.11, and there are many standards that we have. It all started. The first one was released in 1999, which was 802.11a. Then, which had a speed of 54 Mbps, frequency band was 5 gigahertz. Then B, 802.11b, which also got introduced in 1999. The data rate was less, it's just 11 Mbps, and the frequency band is 2.4 gigahertz. G also is works in 2.4 gigahertz bands, and the data rate is 54 Mbps. So uh, the main difference between these two is we all know that 2.4 gigahertz has a better range compared to 5 gigahertz. The higher the frequency, the less would be the travel time. So they are inversely proportional. So A band has less range as compared to B and G, and that is where B had a good range at 2.4 gigahertz, but the data rate was less, which is 11 Mbps. So G got introduced, which gives the data rate of 54 Mbps, but it works in 2.4 gigahertz band. Then came 802.11n, which which started giving us a data rate of 600 Mbps. It works in both 2.4 gigahertz and 5 gigahertz band. Then we have AC, which is Wi-Fi, Wi-Fi 5, which gets a data rate of 1.3 Gbps. And then we have Wi-Fi 6, which is 802.11 AX, which works on 2.4 gigahertz and 5 gigahertz band both. There are further evolutions in this, and those evolutions are like, if we see this, we had Wi-Fi 6, which was 802.11 AX working in 2.4 gigahertz and 5 gigahertz band. Then we have Wi-Fi 6E, which started working on 6 gigahertz band, and Wi-Fi 7, which is 802.11 BE, which operates in all three 2.4 gigahertz, 5 gigahertz, and 6 gigahertz band. And as I said earlier, 6 gigahertz bands is just open in India in January 2026. So we'll start seeing more devices with this technology. Now, if you see the old days, few years back, we had routers at home with only one or two antennas. But in recent days, if you have purchased an antenna or you have seen an antenna, you will see that there are four antennas connected to the router. So that's where as we saw earlier, 802.11n was in 2009, introduced in 2009. And then came further improvements in it, which is MU-MIMO, which is multi-user, multiple input, multiple output. And this standard basically what it does is, in the traditional Wi-Fi or in the initial single user MIMO, if you have a speed of 100 Mbps from the ISP and you connect a router and then there are multiple devices connected to it, the load used to get shared between that. So if it is 100 Mbps and three devices, every device will have 33 Mbps of speed. Wherein in multi-user MIMO, if it's the ISP is providing you 100 Mbps, then you get 100 Mbps speed to each of the device that you connect to. So that's the beauty of MU-MIMO. Oh, okay, just give me a minute. Is the PPT visible now? Let me share my screen again. Is it visible?
Yes.
Thank you. So if it gets disconnected, please let me know. Okay. So in simple terms, in single user MIMO, if you can see this figure depicts it well. Only the first laptop on the top is able to interact with the router, while the others are waiting for their turn to come. Wherein with multi-user MIMO, all of them can interact to the router at the same time. So what are the evolutions of MU-MIMO? It is getting evolved from Wi-Fi 5 to Wi-Fi 7. In Wi-Fi 5, it was 802.11 AC, where the downlink MU-MIMO supporting 4x4 streams was introduced. In Wi-Fi 6 or 6E, which is 802.11 AX, also the uplink was added and increased the streams to 8x8 and introduced OFDMA for better spectrum use. And in Wi-Fi 7, which is the latest, 802.11be, it expands to 16 by 16 mu MIMO and adds 320 megahertz channel. So it definitely gives a better speed and more reliable connections. How it provides a more reliable connection, it will come into the coming slides. I will explain that as well. So again, advantages is simultaneous multi-device communication, optimized network performance, and backward compatibility. These are the main three advantages of MU MIMO. Yeah, so how the RF transmission works in the real world. Now, we know that in the RF world, what we see is the waves when they are transmitted, they hit different blocks in between, each one creating a different type of behavior. For example, as we see in this image, absorption, if it hits a strong wall, signals stops there. They get dead. They just get dead as the material is too dense. If it hits a clean off metal surface, then the reflection happens. If there is a kind of mirror or something, it gets refracted, or window, it gets refracted. That is, the signal is bending when it passes through that medium. Then we have diffraction, signal bending around a sharp object to fill the space behind it. And we have scattering as well, wherein if it hits a mesh like environment, the signal scatters. So how, with these different behaviors, how MIMO helps is it has multiple input, multiple output, multiple channels. They are transmitting and receiving at the same time. So even if are coming from reflected, then coming or to the client, with MIMO, it is capable of capturing all that, collating all that, and then using it to the better. So that's how it gives a better speed and more reliability. That's where the MU MIMO is very important. Then we all, like in the normal LAN world, we all know in the networking, normal networking, we have LAN, we have WAN. Like WAN is wide area network, LAN is local area network. Similarly, we have some things defined in wireless as well. WPAN is personal area network, where the proximity is very less, very small. Bluetooth, infrared, these kind of devices works in WPAN. It's like a device to device coupling. WLAN is what we have been discussing, 802.11. It covers building complexes, big offices, and stuff like that. When we say WMAN, it is metropolitan area network. We can call it a citywide range. It uses 802.16, which is WiMAX, and it is basically used to get the last mile data delivery. And WWAN is wide area network, which is basically cellular. You have the range is national or global, and it's the broadband or the cellular network that we use. So that's how the networks are geographically scaled. Based on your need, you scale or design it accordingly. Now talking about the architecture of 802.11. Okay, in this 802.11, it provides an architecture where you can have the devices connected independent to each other as well. Like I have two mobile device, one computer, or I have two laptops, and I want to connect them to each other without an access point. So that is definitely possible. That is called IBSS, which is Independent Basic Service Set. Here the connections are peer-to-peer, and the individual client machines are called stations, STA. Then we have BSS, which usually you see at home. uh, BSS is basically one access point or router, wireless router. Connect multiple clients are connecting to that one router or wireless device. That is your basic service set. Okay. Then there is something called ESS, which is extended service sets, and this is usually used in offices where the area is too big and one access point cannot provide you the required uh, area of coverage for the wireless clients. So then we connect multiple access points in such a never coverage. Moving our laptop from one place to the other place when we are connected, and we are moving from one access point to the other access point based on the signal strength. As soon as the client sees that there is a different access point with better signal strength and the same SSID and the same password, it just gets connected or hooked to the new one, and then it roams. And this is so this all happens so quietly, don't even understand that the client has moved from one access point to the other access point. It's in the similar way what happens to us when we have mobile phones and we are roaming from one place to the other place. It just moves from one tower to the other tower so easily that you don't understand. Your call doesn't drop and you just move around. So that's how 802.11 architecture is also designed. uh, in 802.11 there are three types of frames. I would say three roles of frame rather than types of.
So you are not audible.
Am I audible now?
Yes, sir.
Strange. Okay, sorry. I don't know where did it stop. Where was I when you heard me last? Was it management frame, control frame, or before this slide?
Last slide, sir.
Oh, previous slide. Is the slide visible? Can someone tell me?
Yes, sir.
Okay, great. So, in the architecture, I will just repeat this if I'm not sure if I have completed this. So, I will start again. Uh, in 802.11 architecture, there are three types of architecture. One is IBSS, which is Independent Basic Service Set, which is peer-to-peer communication. So, two laptops or two client devices can communicate with each other uh, directly without an access point. So, that is Independent Basic Service Set. Then there is something called BSS, Basic Service Set, which is one access point and multiple devices connected to this access point. So this is basic service set. It is working, yeah. Is it working, right? You are able to hear me?
Yes, sir.
Okay. Okay, and the third one is ESS, which is extended service set. Now in extended service set, basically what it is one multiple BSS connected through a distribution system. So we have one access point, two access point, and we have a distribution system connected in between, which is kind of switch, which is the backbone. Uh, so ideally, the diagram should be for ESS is this loop should be something like this, and this should be something like this. So they intercept each other. So when the client devices are moving from this access point to this access point, the roaming is successful without failures. And this is called ESS, which is extended service set. And this is what you usually see in big offices where there are the rooms are too big and one access point cannot provide you the coverage for that area. Then we have three roles or frame types or frame roles in 802.11. I don't know what is happening. It again disconnected. Am I audible?
Yes, sir. Now you are audible.
I don't know what is happening. Let me check my signal strength. Yeah, it is there. Okay, is my screen visible?
Yes, yes.
Okay. So, three types of roles the 802.11 frames has. One is the management. They are basically, these frames are basically the administrators used to connect to the wireless network. They have beacons, probe request response kind of frames. Then we have control frames, which is the traffic cops. They assist with the delivery of the data, acknowledgement frames, RTS, CTS, these are the frames that are part of control frames. Uh, Control frames are very essential because Wi-Fi or 802.11 is half duplex. So it's like a walkie-talkie, only one person can talk at a time. So it is important that we get acknowledgement for the data that we have sent. If we get acknowledgement, then it understands that the data that was sent has been received, and then I can send next data. If we don't get acknowledgement, a retransmission happens. So this again. Okay. I was actually doing it on two different screens. Let me share my main screen and see if that makes a difference. Ideally, I use it for every meeting. Sure. Okay. Let me share my main screen. You are able to see my screen? Wow, my PowerPoint is also on. Uh, is the screen visible?
Yes, sir.
Okay. Okay. We were talking about the management frames. So here we have beacons. This is the access points heartbeat, we can say. The SSIDs are being broadcasted continuously, which this beacon contains all the information like different channels. It supports what is the SSID or name of the network. So this kind of information is being transferred in a beacon packet. Then we have probes. There is a probe request and a probe response, where the client sends a probe request that I want to connect to the access point, and access points responds back with probe response saying that, okay, you can connect me based on your authentication and association uh, mechanism. So if there is any key exchange done during authentication, then that key exchanges are uh, taken care. If the keys are good, password is right, then you get authenticated and you get associated to the access point, and then you can start sending the data. So that is how overall it works. Control frames, as I say, they are request to send, clear to send. These are like traffic cops. They're very, as it's a half duplex, it is important that this mechanism is in place wherein for every data frame sent, we should receive an acknowledgement with which the access point understands or the client understands that the transmission is complete. And that way, with the acknowledgement, it completes that and then starts a new transmission. Similarly, RTS, CTS is request to send and clear to send. If I want to, a client wants to send something, it sends an RTS control frame. And if it receives the CTS control frame that is clear to send, then it's actually starts sending the data. There are other mechanisms like short interframe space, long interframe space. They are very deep. I don't want to get into all those details, but at high level, RTS, CTS is a control frame that is needed before sending the data. Then, yeah, this RTS cities we just talked about. And then how these wireless clients are getting connected to the access point. So for that, there are two types of scanning: active scanning and passive scanning. So when a client wants to connect to an access point, connect. So while doing that, the scanning happens with active and passive. In passive scanning, client is just listening to the beacon frame. Beacon frame, as we said, is a management frame. The client keeps listening to the beacon frame. As soon as it gets the beacon frame, it checks whether the same SSID is also configured in the client. And if it is configured, it tries to connect to the access point based on that SSID. In active scanning, client doesn't wait. It just sends a probe request. And after it receives a probe response, it connects to the access point. Now, if the client is already configured with the SSID, then it can send the SSID in the probe request. If it is not configured, it will just send a probe request saying that, okay, is there any wireless access point available? And then if there is any access point available, there may be multiple access points available. Say, for example, you are on a street and there are two different shops having two different access points connected. You get signals from both. So that way, a probe response is received from both of them. And then based on different parameters, like which one I want to connect to, the client wants to connect to, which is the better signal strength, it connects to that SSID, and then it gets connected or associated to the access point. So overall, the state machine for 802.11 is like initial state. It is unauthenticated and unassociated. This is where the discovery happens. And if it gets authenticated, am I not audible?
Sir, now you are audible.
I really don't know what is happening. What better I will do is I will turn off video and see if it works fine. Okay, let me share my screen again. Please करता ना चलो. Okay, are the slides visible now?
Yes, sir.
Okay, so we were on the state machine. Okay, so basically the first stage is where the access point or the client is in unauthenticated and unassociated state. There is where it starts with probe request and probe response, which are the management frames. Then it gets authenticated. So the authentication request and authentication response frames are transferred. At the second stage, the client gets authenticated, but it is still not associated. Then there is an association request sent, which for which it gets an association response. Then the third state completes where the device is authenticated and associated. And once the device or the client is authenticated and associated, it gets the full access to the network, and then it can start sending the data, which is the final and the fourth stage. So again, how this happens is beacons are the broadcast packets. They gets broadcasted. Let me share my main screen again and take this. Okay, so beacons are basically packets or frames that are sent from access point to the station or the client device. Then we have probe request, probe response. Then we have authentication. Windows. Just a moment, guys. Speed. Okay. You are able to see my slides, right?
No, sir.
Oh my God. Now you are able to see it?
Yes.
Okay. Okay. So beacons are packets, frames that are sent from access point to station which are broadcast. Then we have probe request sent from client to access point, probe response from access point to the client again. Then authentication request, authentication response, association request, association response. So this is how it works. Then as it is wireless, we understand that there will be threats to it, right? So let's talk about the threat matrix of 802.11. There are majorly four categories of threat matrix. One is the infrastructure compromise. This is where the infrastructure of your network gets compromised. Like a rogue access point is being connected in your network. That's infrastructure compromise. Then the other type of attacks are cryptographic or authentication. Then we have in here we have encryption which is getting cracked, like WEP, WPA are getting cracked. Then we have protocol or medium, where the manipulation of 802.11 clear text frames and RF spectrum are done. As I was talking about the beacon frame, uh, beacon frame actually transfers, and it's a broadcast frame, and it transmits a lot of information that is plain text, like what channels it supports, what security mechanism it supports, what is the network name or SSID that it has. So these information can be used by the hackers as it is in the clear text. So there can be an attack using the protocol or the medium itself, like eavesdropping, max spoofing, etc. Then we have endpoint and human, where the exploitation is uh, through the user or the device. It can be a peer-to-peer or vendor exploits or social engineering. So talking more details about it is rogue wire access point, wireless access devices that are connected. So this is your network where you have a radius server, we have authentication mechanism, AAA mechanism configured. We have access points in this, which are safe, secured, which are configured through WPA2, WPA3, or through radius server 802.1x. Okay. However, what happens is in your switch, someone just extends it and connect a rogue access point with the same SSID that this has. Okay, so this is rogue wireless device. So A rogue access point is an unauthenticated Wi-Fi device connected to the wired infrastructure, and it can have no password, so anybody can connect, and then you are in that network. So basically, that gives you access to the entire network. Now, this is not very easy, because you need physical access to the your network. You connect your access point to your switch or in your network, which needs a physical connection. So it's usually done by not it is not done by external hackers, it's done by someone in your company or in your workplace, just because they don't want to get authenticated through these mechanisms. They just want to have easy and open access. So that can be a way of doing this. However, it may be intentional or unintentional. Someone may do it intentionally, and someone may be unaware that it might create problems, and they can connect access point, which should not be done. Then we have interface exploits as well. Like, attackers target the management interface of legitimate access point of or WLAN controller via default settings. So usually, if you the access point or routers that we have at home or in the offices, they are from a particular manufacturer whose documentation clearly states what their default IP address is and what their username passwords are to connect to them. So this makes it very easy. If you know what type of router it is, you can know the IP address. If you have not changed the IP address, then someone can get access to it through that, through the default IP address and default username password, and they can then exploit it. They can change the firmware, they can do anything, they can alter the routing tables as well. So that is also an issue or an exploit. Then there might be peer-to-peer attacks, like they are connected to one access point, but then one client can have an attack on the other client on the same subnet. However, this is not usually a case, but again, if someone wants to do something purposefully, that can be done. Then we have eavesdropping metrics, where there can be a casual eavesdropping or a malicious eavesdropping. In casual, it is like a WLAN discovery, where the open source apps like Wi-Fi Analyzer, indeed Wireshark is also open source. We can use that, get all the information from the beacon or probe request, response, where this information is in clear text. We get SSID, MAC address, the BSS capabilities. So this is not harmful. This is just like getting the information but not using it to a bad with a bad intent. However, there are malicious eavesdropping, where these analyzers are used, they are monitored, and then uh, the data that is being transferred, like for example clear text emails, if you have any internally, you have a telnet or an FTP session, these kind of sessions transmit their username and password in clear text when they transfer over the network. So if someone captures the traffic using OmniPeak or Wireshark, they can get the username password uh, in clear text. They can also enter IP address also, so they can enter with that device using that username and password, and they have access to that device and to the entire network. So that's a big problem. So this is illegal, should not be done. Then we have cryptographic issues, like as I said, if a static web, initial days there were the security was used was WEP web, or a crack attack was very easily possible. In this, there is a plain text IV and a secret key that is sent along with the plain data. An RC-for algorithm is used, which is a streaming cipher algorithm. And if we capture around 5,000 to 10,000 IVs, then it is very easy to crack this WEP password using the tools. So this is not a good security stuff. Nobody is using it these days. Web, nobody configures. Then there can be brute forcing attack, where the passwords for WPA, WPA2 personnel, these basically, when the PSK key, they rely on static passphrases. So once they have access to the static passphrase, they can also get access to the PMK, and they can get easily, these passwords can be decrypted. So as a practical example, we will also see today how we are going to crack a WPA2 password. So this is where they first capture, as a first step, they capture the packets, then they collect that packet. It can be done offline or online, and then they can use tools to brute force and get the password. Spoofing is very common. It can be used in two ways. One is try to show that you are a legitimate MAC address of your network. So change the MAC address of your device with a different MAC address which is legitimate to the network, and then try to connect to the network with that MAC address. Or even it is used in the incorrect way, where I want to hide my actual MAC address and use a fake MAC address connecting to the network, so that it is not easy to connect to me, because MAC address is the physical address, whereas IP address is a logical address. So MAC address is something which identifies what is the make of that device. So it can still be tracked if we use the right MAC address. So spoofing is one way that hackers can use to change their MAC address. So there is also something called evil twin or wireless hijacking. What is done is, say there is a legitimate access point in your network, and another rogue access point with same SSID, open credentials, and different channel is connected into your network, creating a evil twin. Okay, then it the attacker jams the original signal AP6, so that the client tries to connect to the same SSID on a different channel to this rogue access point. That way, the evil twin DHCP issues an IP address, and then with that IP address, it gets entered, or it is easy to get details of the network. So that way, an evil twin attack can also be done. Then there is denial of service attack. Uh, they are at two layers: layer 1, layer 2. Layer 1 is RF jamming. This is like signal generators flooding the unlicensed frequency. Like 2.4 uh, is a standard everybody uses. Like we saw, Zigbee uses 2.4, Bluetooth uses 2.4. So you might have observed this at home sometimes, that when you are connected to 2.2.4 gigahertz network on your WLAN, and you are interacting or you are working on something, and if someone at the home starts the microwave oven, which is also on 2.4 gigahertz, so it might create an interference, due to which the signal may get disconnected. So that way, an RF jamming signal, there are signal generators that flood on the unlicensed frequency, 2.4 gigahertz, 5 gigahertz, and then those that creates an interference, basically breaking your or jamming your network, wireless network. How to detect it? We need a hardware spectrum analyzer to detect it. At layer 2, it's again spoofed deauthentication or deassociation frames, forcing the clients to go off the network. This also example we will see when we are doing the practical. So how it works is, it the the hacker can send a deassociation or deauthentication packets to the client, and then the clients gets disconnected. So that way, clients gets disconnected and again tries to connect, and it does the handshake. And so that is very much possible to be done. And how is something that we'll see in our practical session. How it can be monitored? It can be monitored through WIPS. WIPS is wireless intrusion prevention system. The other exploits are the vendor exploits and the social engineering exploits. Vendor exploits are basically We have access points working at our home since years, and we don't upgrade the firmware of it. And there might be issues, uh, security issues related to that, new security issues coming up on the firmware of that access point. And if we are not updating it regularly, it can be an exploit. As I said earlier, the if the username and password is not changed and IP is not changed, it's usually well known to the people of how we can connect to it. So this is one type of problem. The other is social engineering, where manipulating employees to divulge static credentials, like sharing the passphrase key to get connected to the network. That's the social engineering exploit. How do we mitigate it? What is the defense for it? The defense is WIPS architecture. WIPS is wireless intrusion prevention system. Okay, how this works is, there will be a WIPS server, and there will be multiple WIPS sensors that are connected in the network. These sensors are wireless networks that work in the monitor mode. This monitor mode is something where it does not participate or connect to the access point, but it keeps listening to the data that is being transferred from the access point. So if you try to connect the dots, first I said it is half duplex, Wi-Fi is half duplex. Then I said each device can only connect once, and the other device waits for its turn to get connected. So all the communication that happens in the network happens through the access point. So these WIP sensors does not connect to the access point, but keeps sensing or capturing all the packets that are being sent to and from the access point. And as soon as it identifies that there is some rogue device connected or rogue access point connected in your network, it sends a deauth frame to the clients. As soon as the clients get the deauth frame, they get disconnected with the access with this access point. And then this server is sends a SNMP port separation to the managed switch where it is actually connected. So it gets information like what is its MAC address. It goes to the switch where we have a MAC address table in the switch. It checks the MAC address, and then this SWIP server tells this switch that disconnect this port from the network, that shut down this port. That way, wirelessly, this device gets disconnected, and through the deauth, through this port separation, the access point also is getting disconnected from the network. So WIPS architecture is something which can be used in such kind of scenarios. Then there are some governance or wireless policies that we should strictly follow. Like general policies are establish an overall authority and acceptable use, ensure legislative compliance, mandate regular security audits, then check for rogue AP policy. If we see anything like that, uh, there should be zero tolerance. It should be told to the employees that this is not allowed, you should not do this. Access remote access policy, if you are in a public place, for example GitLab, my lot of source code is in the GitLab doesn't need a VPN, it's on cloud. So you are in a public place, you can connect to the GitLab account directly, which can be a bit unsafe. So it is better you connect through VPN and then connect to the your GitLab, which makes it more secure. Similarly, credential management restrict sharing of passphrases to enforce 802.1x where possible. No overall threat and mitigation alignment matrix. Um, Rogue APs, it's at the infrastructure level. Exploitation is at layer 1 and layer 2, and defensive mechanism is WIPS or 802.1x port control. Peer-to-peer or ad hoc is endpoint level at layer 2, layer 3. Client isolation should help. Eavesdropping and is at protocol layer at layer 3 to 7. Better encryption mechanisms like AES, CCMP should help here. Max spoofing, evil twin, they work at layer 2, layer 3. Just abandon the MAC filters. Mutual authentication should help. on offline brute force cryptographic issues, layer 2 have better passwords. So if you see in offices, you have a strict mechanism where you have to enter minimum 12 characters password. Only then you are allowed to have a password. So, and it should have numbers, capital letters, small letters, all these different combinations, special characters, all these different characters with a bigger character password or bigger length password makes it difficult to crack. So it is important to have bigger character passphrase or dynamic keys. And then layer 2 DOS, again, VIPS anomaly can help us here. Now talking about the security, uh, as I said earlier, WEP, it was very old, working on RC4 algorithm. It was introduced in 1997. Then we had WPA in 2003, which uses tkeep and RC4 algorithm. WPA2 was also long back in 2004. WPA3 is much better and safer, which was introduced in 2018. Uh, these uses 64-bit and 128-bit keys, wherein it supports up to 256-bit session key. So at high level, it is important that WEP, WPA, WPA2 are comparably weak compared to WPA3. And if you want to use WPA2, then use a better long passphrase, which will help you to which will make it difficult to crack the password. Now, if we see wireless setup, um, we can see this is a Linksys router. Uh, we have this network mode which is mixed. Uh, we see SSID. We can set channel width. All this information we can set up here. If we go to security, we see that there are different types of securities that we can enable with WPA2, WPA2 personal enterprise with radius server. So these are all mechanisms that we can set up to make it better or robust. This is another example of geo fiber router where we see we can enable and disable broadcast. So one more point to add is this broadcast SSID. There is a mechanism in most of the routers where we can disable the broadcasting of SSID. So as I said that uh, in management frames we had something called beacon, and beacon sends broadcasts the frame, and it has SSID in the clear text. So if we hide this, then the SSID is not broadcasted, and that it's we safeguard the wireless network. That is something that is available in routers, but that is not true mechanism for safeguarding your network, because in probe request and probe response that we get from the router, again the SSID is in the clear text, so that cannot be hidden. So this doesn't help us much, but yes, for normal users it can still be useful. Then there are different modes of wireless NIC connectivity. Okay, in this there are four modes. One is ad hoc mode. In ad hoc mode, the clients are connected to each other without an access point. This is like an IBSS that I showed earlier, independent basic service set. It is also called ad hoc mode. The nodes connect to each other without actually having an access point in the network. In this particular case, these nodes can also transmit the beacon frames. In all other cases, when it is not working in an ad hoc mode, only the access point sends the beacon frame. In managed mode, this is the normal mode that we use at our home or in the offices. We have a wireless router or an access point. We have different nodes connecting to this router. So that's called a managed mode or a BSS, basic service set. Then we have a master mode. Consider this master mode as a wireless hotspot. So you might have definitely used this feature in your mobile phone, where you enable hotspot, you get the internet from your mobile SIM card, and you enable hotspot on your mobile, and then you connect different devices to your to that hotspot. It may be a laptop, it may be another phone that gets connected to the uh, to the to the mobile phone through the wireless hotspot, and then that another device starts getting the internet. Okay, that's the master mode, where the master node works as a wireless hotspot. And then comes the monitor mode. This mode is important for us for the further discussion, because as I said earlier, monitor mode is something
देखा था आपने चेक पे
the VIPs.
सौरभ सर से पूछा मैंने, सौरभ सर कह रहे कल मैम मैं ले ही नहीं पाया, मैं बहुत बिजी था अदर्स काम में, अदर्स वर्क में।
Yeah, okay. So in monitor mode, uh, these modes, as I explained in sensors, WIPS sensors, in this mode, the wireless NIC card acts as a monitor mode, where it does not connect to your network automatically, but it just listens to the traffic that is coming into the network. Okay, that way monitor mode works, so that these NIC cards, these are specific NIC cards, that our regular NIC card that we have in our laptop that connects to our access point does not work in a monitor mode. It works in the regular client mode, but for monitor mode there are specifically designed network cards that can work as a monitor mode and listen or get the information from the network, wireless network. Okay, why this is important? Because only in wireless mode it can listen to all the channels, and it can capture the frames, beacon frames, probe request response, all these frames it can capture. And after capturing, then it we can then use it for understanding of how actually the wireless network is working. Okay, so this monitor mode is important. Now let's try to understand about how and what we will need to actually run run this. So Kali Linux is something you might have listened or used. So it's an OS with tools installed in it, different tools which can help you for scanning and sending deauth packets and multiple stuff. You can do all kind of hacking using different tools that are available in Kali Linux. You can do hashcat, you can use hashcat for password cracking. What hardware we need? Hardware requirements are the wireless adapter, as I said, in the monitor mode. Let me see if I can turn on my camera and show you this node. Okay, this works in monitor mode. Okay, it's a separate device connected through USB to my laptop. Then we will need Kali Linux installed, and then we can use a dedicated test router, which is isolated network, or currently I will run it on our own network. Then software setup, we need Kali Linux installed, we need this wireless adapter, and we need different suites like Aircrack NG and Wireshark installed on Kali Linux, which are by default installed on Kali Linux. And then we have legal and ethical framework, where if you are testing it on your own network, you are good to go. If you are using someone else's network, you should have a legal and ethical authorization to hook or to connect to someone else or break someone else's network. So ethically we have to do it. If you are trying this, you should try only in an isolated network, or you should use your own Wi-Fi network to crack the password. You should not do it on someone else's wireless network. Okay, and everything should be documented if you are doing it ethically and you are doing it for someone else. What are the hardware requirements? As I said, we need a separate monitor mode supported NIC card that I just showed you, and these are few models that support monitor mode. So from Alpha, this is the one that I have. Then no, this is the one that I have. Then we have TP-Link, Alpha, TrendNet, and multiple other vendors who provide us the Wi-Fi adapters with this monitor mode support. Then some introduction to the Kali Linux. It is Debian based. It is purposefully built, and it has almost 600 plus penetration testing tools. It's easy to install. You just get an ISO and you can install it on the virtual box, virtual based environment anywhere on your computer or on server if you have any. So it's simple to install and use. For wireless specifically, we need the wireless driver support with monitor mode. We need pre-installed networking tools and packet injection capabilities. Now, these are the phases of ethical hacking. How this works is basically first step of ethical hacking is reconnaissance. In this, the hacker tries to get as much information as possible about the system that we are going to hack. Okay. For example, usually it's an habit for anybody of us. When we are setting up a password on any device, we set up in such a way which makes it easy for us to understand. For example, it would be name of the member of our family. It would be on some of the god's name. It would be on birth dates. It would be on phone numbers of the member. So this reconnaissance stage is the stage where you try to gather all this kind of information of the system because you need it later. We need to create a word list that I will show in the future slides. That is where you need this reconnaissance stage where you try to gather the information as much as possible for the target system. Then comes scanning phase. In the scanning phase, we identify which ports are open, which devices are active in the network, and then we try to target a particular device on a particular port which is open. That's where scanning comes into picture. Once the scanning is done, it's gaining access. Now, gaining access is something like the hackers uses the vulnerabilities discovered. Like for example, uh, for example, Telnet is a classic example. Now, Telnet sends the username and password, FTP also sends the username and password in clear text over the air. So, if someone gains access to your network and he starts listening with the wireless mode adapter and he captures the data, he gets the IP address, username, password, everything of that system. He can gain access to that system, and then once he has access to the system, he's actually into the network. He can do anything that he wants. Okay. Then maintaining the access. So once you have gained the access, now you try to maintain that access so that the more time you are in this network, you try to capture more and more data. And why maintaining access is important is, again, as I said, if we use mechanism like WIP, sensor, and server, as soon as we realize there is something rogue happening, we can just break that. And covering the track. So at the end, even if someone identifies there's something bad happening in the network, your presence should not be identified. It should not be possible to ensure to understand which person was actually doing it. That is where the MAC spoofing comes into picture. You can hide or change your MAC address. So these are the phases of ethical hacking. Now let's do something practical. Okay, I will open up Kali? Okay, you might have heard about the tool Nmap. Okay, Nmap is basically network mapping. So this tool has capability of running scan on a particular IP address or running scan on the entire subnet to identify which devices are active or turned on, what ports are available or open on that particular system. These open ports will help the hacker identify what can be the easiest way to get into that system. Okay, that way network mapping or nmap tool, this is very good tool. It's used by almost everybody, and it also helps. For example, in practical world, how we use it is, it is not always hacking. It is quite possible that I want to know, I have multiple servers and multiple VMs running on the servers with different IP addresses, and many people are accessing them. So if I want to understand what all IP addresses are actively being used by my team members, I can run nmap on my subnet and I know the IP address of the active VMs running in the network. That way, I can then identify how many IPs are still available, how many more I can still create. So that way we can do it. Let me show it. And there's another tool, Zmap. Rather than doing this on CLI, there is a tool called Zmap where you can actually run it on uh, this using UI. So let me open that. Let us make it more easier for us to understand rather than writing commands. What is that? Okay, the tool is opened. So here we can just write the IP address of the target, say 192.168. I want to do it on my network to see which systems are available. I will check the IP of the network. It is 29, 192.168.29. So 192.168.29.0/24/24 is class C address, and I will run the scan. So see, the beauty is when you are doing it in nmap, you have to write this command by yourself, like nmap -t4 -a -v and then this, wherein in zenmap it writes the command by itself. All you have to do is the give the target, and then you can use different profiles. It can be in intense scan, it can be a normal ping scan, it can be a quick scan. So let me run a quick scan to make it easier and faster. Now it has started looking for the network. Yeah. So we see it says there are 94 filtered ports. These are all the devices that are available. It shows me there is a router with these ports open. Then I have these devices with these ports open. So this is the depth of uh, data that we get when we scan. Again, we are running this as a quick scan. If I do a intense scan, it will take some time, but it will show you more additional data as well. So this is the way where we scan to a network or a subnet. We try to identify which IPs or which devices are active with what IPs, and we can also know what is that device and what are the ports open on that device. So this is a very good tool. You should definitely try this. Then uh, moving towards the other tools, we have different tools for wireless security and hacking like Aerodem, NG, Kismet. TCP dump is similar to Wireshark. TCP dump, I'm not sure if you have heard about it. Uh, Consider it this way: in practically what we do or what we see is there are a lot of devices in the network that do not have UI access. They only are built with small operating system, needed only with few packages like networking related packages to connect that device to the network. So they are small OS, Linux small OS built specifically. This is possible in Linux. We can build small OS with only the necessary requirements that we have. So we don't have to have a full blown OS or a big OS. And this is used on small devices where the RAM and CPU of the device is small and the hard disk is small. So those kind of devices do not have UI to connect to, and that is where TCP dump comes into picture, where TCP dump is similar to Wireshark. You can select the port or the NIC interface on which you want to take the capture, and then you use run the TCP dump command, capture the files. You can see it on the screen, or you can capture that PKF file, open in the Wireshark on a different machine where you have UI, and you can still understand what's happening in the network. So TCP dump is a very good troubleshooting tool when you have issues in the network. Then we have AirPlay NG, WPA, WPA2 handshake capture, and then rogue evil analysis. If we do not have monitor mode, we will not be able to listen to the probe request and beacon requests and stuff like that. Then network scanning, we use different tools: AirDump, NG, Kismet, Wi-Fi, Wash. Uh, okay, let's do this. Okay, for a monitor mode, device to be in the monitor mode. Now I have connected my device with a USB, and I've just connected it. We see that device in USB. Uh, we connect to it. It's not. Yeah, it got connected. Okay. Now I have done IPA here. You see that there is no wireless card available. I will do an IPA again. Now it started showing me WLAN card as well. Okay. Now I want to start enable mode, monitor mode on this wireless adapter. So I will do AirMon NG. Airborne NG start. WLAN 0. Now to check if it is in the monitor mode, I do IW config. It shows me that it is in the monitor mode now, right? And once it is in the monitor mode, I can run this command to see what are the different wireless networks that are available. Okay, air dumping. Now you can see this aerodump ng command. It has started looking at all the SSIDs that are reachable from this client. So I will just stop it here. It keeps scanning. I don't want to run out of this page. So these are different access points that my monitor mode NIC card is able to identify and see. It also identifies what are their power levels, how many beacons are transferred, what is the channel they are currently working on, right? What kind of security it has. It has WPA to CCMP. Most of them has this with a pre-shared key. And what are their SSIDs or the network name? Okay, so this gives all the information that we have, and also it shows what clients are connected to the BSID. So we see C89C. It should be somewhere here, C89C. And for this BSID, this is the client that is connected, station that is connected. So we get a detailed information on what is going on around us wirelessly. All that information we can see using this tool. However, this tool is what you can say, it is a CLI based tool. We have some very good GUI based tools as well. That does the same for us. So it is sending you the information. You can open it in the browser. Okay, local 201. So I ran this tool from the CLI, and then I opened up the browser. Localhost 2501 is the port with which I can connect to it. And then I start seeing all that information that I was seeing on the CLI. I can see it here on the UI as well. Plus, it gives me additional information like what are the channels configured, how many devices are configured on this channel. So overall, in my environment, there are on channel 1 there are 14 SSIDs that are being transmitted. So this is all the information that you get. Uh, there is more. You can connect to any one of them. You can go deep. It gives you a lot of information about that. So I go to Airtel Kulkarni, for example. See, it gives me the number of characters the SSID has, first scene, last scene, what is the encryption it has. Then it gives me view device details. I can view the device details, the MAC address of the device, what is the manufacturer of the device, it's a Wi-Fi AP, what is the channel it is transmitting, what is the frequency it is transmitting, what is the signal strength we have. all this information is readily available in front of you when you are using these tools, uh, along with the NIC card which is in the monitor mode. Then we can also run Wireshark just to show everybody how these frames are seen. So let me run this. Now this monitor mode NIC card is receiving all the data that is in my network. I will just stop it. We can go to any of the beacon frame. Okay. And when we were seeing earlier that beacon is a management frame. Okay. And what all information it has, if you try to get more details, it will say that it is 802.11b. Okay. And then it is on channel 3. This is the frequency that it is transmitting on. Then you can get more information. Beacon frame, right? It gets the because it's a beacon, the destination address is a broadcast because it is broadcasting the beacon, so it is FFFF. Then you have fixed parameters and you have tagged parameters. You see SSID. Now as I said, it's a common practice in people. When you see this is our neighbor. It's my neighbor's SSID. So they are running with this SSID. Their supported rates are 1, 2, 5.5, 11 Mbps, 6, 9, 12, 18 Mbps. They are currently on channel 5. So, and the extended data, supported extended data rates are this. So you get a lot of information. The more you learn, the more you have, kind of. So uh, Wireshark again is a very good tool that everybody who wants to understand networking should definitely run Wireshark once and try to understand how the packets are behaving. Okay. Then we have done Aerodum. We just saw that we can do that through UI as well. We can run the command to capture the file as well. We can run this command wherein we want to run it on a particular BSSID on a particular channel and write it to a test file. Then the test file cap file is created, which we can use further for analysis. Kismet is the tool that we just saw. Now, okay, we talked about how to crack WPA and WPA2. Okay, for cracking WPA and WPA2, two things are very important to understand. One is four-way handshake that happens between the client and the access point. So that four-way handshake is basically uh, an client and AP, and A nouns is sent from AP to client. A pair-wide transit key, which is PMK, A nouns, S nouns, AP MAC, and client MAC are sent, derived from the Wi-Fi password. Then MIC is also used. So once the A nouns is received, it constructs the PTK. S nouns plus MIC is sent. Then AP constructs the PCK. It sends GTK plus MIC, and at the end it gets an acknowledgement. And once the acknowledgement is received, it means the handshake or the authentication is complete. So this is the four-way handshake that happens while a client communicates with the access point. Now, why this is important? Because in this particular four-way handshake, all these PMK, PTK, these passwords are constructed and sent and transmitted. They are not in clear text. They are all we cannot understand them easily, but uh, these capture are essential for the tools to use these captures, and from based on that capture they identify the password. So this four-way handshake capture is very important while we are doing a while we are trying to crack a wireless password. Okay. Then another important thing is word list. Okay. Now, why word list is important? Word list is a text file containing a large collection of possible passwords, usually one per line. It is used in cybersecurity and ethical hacking during dictionary brute force attacks. Now, at start when I told you that passwords, how we set, we usually set it based on the name of the people, birthdays of the people, or a combination of that. So this word list is basically creating or thinking of what can be done or what can be the password of the person. So we create a word list with what we feel, and that is why reconnaissance stage comes into picture of the ethical hacking, where at the start we try to gather more and more information of the wireless network that we are going to hack. So we create a word list. This word list plus this four-way handshake, the combination of these four gives you, helps you to crack the password of the wireless network. Okay. Now aircrack ng is used for wireless, hydra is used for like ssh or ftp login cracking. That there are other tools, hashcat, john the ripper, that can be used. There are default word lists in Kali Linux stored at user share word lists, uh, and it's rocku.txt file. There are lot of uh, information in this. There is another one which is checklists, which also available. So let us just open that. It's cd user share word list. If we do ls, I see rocku.txt, and if I do cat rocku more. Okay, now why I did more is, if I do not do more and I just run .txt, you will see that these many IP addresses, they don't, it is not stopping. It's a huge list. So it goes very fast. So what I did is, instead of doing that, I just grabbed, I just piped it, and I just wrote more. So what it does, it opens the list page by page. Then you can just click on the spacebar and it goes down. So this is the huge list. Now if I want to see the count, I can just go to vi editor, and I go to shift G, which is the last line of it, and it will tell me that it has these many number of lines. I won't calculate that, but it's a huge number. These many lines of, each line has one password kind of. So this is the default word list that Kali Linux provides. Okay, based on the passwords that are cracked in the past, this list is being created. Okay. However, when we are doing hacking on a particular system, it is essential that we create our own word list based on the reconnaissance that we have done. Okay, for that, there are different tools that help us create the word list. So Crunch is one such tool. CWL, CUPP, and PWGen are the tools that we can use. uh, Crunch tools is used to create the word list, length of password, character set, patterns. If we do man crunch, you will see how we can do that. I think I broke again. Am I audible? Can someone tell me if I'm audible? Yes. Okay. Thank you. Okay. So how to create a word list using the Crunch tool is, we can have something like Crunch 8, 12, like minimum 8 characters, maximum 12 characters. What all can be there in the password, and we can have minus t, that, and this is what I feel. For example, the password that we have set is starts with kr, then dot 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 dot, or at the rate, and it will end with 5, and I write it the output in the word list.txt file. So if I run this command, it will generate a word list. Okay, so let us run this. I am in word list ls. Okay, so I can run crunch. It was 8, 12, this. Okay, so I will say it is 6, max is 10. I will make it simple. I will say it can have numbers from 1, 2, 3, 4, 5, 6, 7, and 9, 0, and minus t. And what can be the password? For example, it's my mobile 9922 ends with 5. Okay, and then I write the output in krishna.txt. Okay, perfect. So I run this. The maximum minimum number should be the same size of the pattern you specified. Okay. See, crunch will now generate the following amount of data. Okay, 100% completed. Now, if I see, open up krishna.txt, you will see it has created all these different passwords based on my word list. So if I see shift G, which is the last line, these many combinations of passwords are created here in this word list. Okay, so now what we were trying to say here, if you want to crack a password, we need two things. One is the four-way handshake and the word list. Okay, now I already have a four-way handshake taken in the past, so I will not do that again. And I have created the word list as well. So what I will do, there is a very good tool. There are many tools that does this. We have Kismet, we have Wi-Fi. Then there is Fern Wi-Fi cracker. This is one that I feel which is very simple to use. So I will just show this tool. It has a good interface. What it does is it asks you to select an interface. We select WLAN 0, which is my wireless NIC card in the monitor mode. Okay, I have got this. Now it says scan for the access point. Okay, I will just click here. It starts scanning. It is active. Now it is trying to detect if there is any BSSID or any device or access point with WEP password. Uh, when we saw earlier, there was no device with WP password. Nobody uses it these days. But we see there are 922 detected WPA. So I will click on this. Okay. Now here you see all the SSIDs that are in my network. Now I select mine because I don't want to hack others' network. Okay, it says that it is already there. The key is already detected. So what I am doing here is I have given it the WPA to crack.txt file. Okay, if I browse it, it is available at I'll just open in the normal emulator. It goes to Kali home. Okay, ls. I have this word list file here. WPA crack. Okay, so it is stored here. I go to the fun Wi-Fi cracker. My screen is still visible.
Yes, it's visible.
Okay. I go to fun Wi-Fi cracker. So this, I have this cracked file. Now I say start attack on my network. Okay, it says key already exists in the database. Do you want to attack and update the already saved key? I will say yes because I want to run the test again. Now what it does is it okay. I'm sorry. I think it's breaking for some reason. Okay. Now you see, as I said, there are two things that are important. One is the four-way handshake, and other one is the word list file. So what it did when I started the attack, it identified which clients are connected to it. It sent a deauthentication to this client. As soon as the deauthentication was sent, the client will try to reconnect it. And while reconnecting, it will do a four-way handshake that we discussed. So based on that four-way handshake and the EA-poll packets that it is receiving and the WPA2 crack, okay, and the WPA2 crack, it is able to crack the password. I've started my sharing again. So now you see that it is trying to go through each and every combination of the password that I have in the word list that it was created to Crunch, and then it runs through each and every one. Now it's 9914, mine is 9922. So once it reaches there, it will try to get the right password, and then it will show me that the wireless network is cracked and what the password is. So any questions you have? It will take a couple of minutes, let it run. So it's trying each and every combination that is available in this WPA2 crack.txt file, which was created to Crunch tool. And now as soon as it reaches to that, yeah, so it reached to the key and it identified that my key is this. It's the mobile number. So this is how we can crack a wireless network. And to crack wireless network, we have multiple tools. Fern Wi-Fi Cracker is one of the easiest tool I have seen. There are others, Wi-Fi, Aerodum. They are combination of UI and CLI, but this is the easiest tool with the with UI. Yeah, I think that's all from my side. Any questions? Uh, Kiran ma'am, any questions that we want, or we can close the session?
पूजा मॅडमला हो अल्टरनेटिव्ह देणार विना मॅडम गावला गेले पटेशनला असतो
Participants, do you have any questions? Okay. I thank our expert. Am I audible?
Yes, you are now.
Kiran madam.
Yes, ma'am, you are now audible. Deepali, ma'am, are you there?
For an excellent session on it. हेलो नाही होत आहे आवाज येत नाहीये
आता येतोय मॅम.
So your practical approach and deep knowledge on investigative techniques have truly enriched our understanding. Thank you, sir, for your valuable time and for making day 4 of this FDP truly memorable. I sincerely thank all the faculty members present here. The quiz and feedback link is shared in the chat box. With this, we conclude day 4 of the FDP. Thank you all.